In this lesson, we will discuss the Air Data Inertial Reference System, ADIRS. The Air Data Inertial Reference System, ADIRS, is the main component of the navigation system, providing flight and navigation data. Flight data, such as air data, attitude, and velocities, ensure the control of the aircraft trajectory. Navigation data, such as latitude and longitude, heading, and time, determine the aircraft position and orientation. The ADIRS is comprised of 3 individual Air Data Inertial Reference Units, ADIRUs. Each ADIRU is made up of 2 parts. These are the Air Data Reference, ADR unit, and the Inertial Reference, IR unit. Both the Air Data Reference and the Inertial Reference can operate independently. The Air Data Reference Unit computes the air data parameters using data from different probes. One multifunction probe, MFP, per air data reference provides total pressure, total air temperature, and angle of attack measurements. One side slip angle, SSA probe, per air data reference provides the side slip angle. 2 static probes per air data reference provide static pressure. A 4th angle of attack, AOA probe, provides additional angle of attack measurements. 2 outside air temperature, OAT probes, provide static air temperature on the ground only. All the probes connected to the air data references are automatically heated to prevent ice formation, except for the outside air temperature probes. The Air Data Reference Unit provides the following air data: total pressure, static pressure, altitude, Mach number, computed airspeed, true airspeed, total air temperature, static air temperature, vertical speed, angle of attack, and side slip angle. The ADIRS data is displayed on the PFD, ND, Integrated Standby Instrument System, MFD, and the Permanent Data Display. The ADIRS has 3 fully independent sources of air data parameters. With the Integrated Standby Instrument System, which is independent from the ADIRS, the aircraft has 4 fully independent sources of air data. The Control and Display System, CDS, normally uses the ADIRS for display on the PFD, but in the event of loss of air data from ADIRS, the Control and Display System can also use the Integrated Standby Instrument System for display on the PFD. The Inertial Reference Units provide the following inertial reference data: navigation information, attitude information, and heading information. Each inertial reference unit uses data from its internal gyrometer and accelerometer sensors. Each inertial reference unit also receives Global Navigation Satellite System GNSS data from both multi-mode receivers, MMRs, for initial alignment and for the computation of the Global Positioning and Inertial Reference System GPIRS position. The ADIRS is controlled using the overhead panel and the MFD. The ADIRS panel includes controls for both the inertial references and the air data references, consisting of an inertial reference mode selector for each inertial reference unit, an air data reference push button for each air data reference, an inertial reference push button for each inertial reference unit, and an on battery light. The controls are arranged in a 1-3-2 format, with ADIRU 3 acting as a backup for either ADIRU 1 or 2. The inertial reference mode selectors have 3 positions: off, navigation, and attitude. In the off position, the selected ADIRU is unpowered. Navigation is the normal mode of operation of the inertial references, and it provides navigation, attitude, and heading data. Attitude is the abnormal operation mode of the inertial references, and it provides only attitude and heading data. The attitude mode can be used in flight and may provide a means of regaining some inertial reference data following a failure. During normal operations, the inertial reference push buttons are on with lights out. When an inertial reference push button is pressed, the inertial reference turns off, and the off light is illuminated in the push button. An illuminated amber fault light in the inertial reference push button indicates that the inertial reference has failed. When the inertial reference fault push button is pressed, the inertial reference unit is turned off, and the fault light goes out. All information about the aircraft position, navigation modes, position accuracy, navigation accuracy, and aircraft time reference is available on 6 specific position pages on the MFD. The flight crew can access these pages via the position menu on the general menu bar. Each ADIRS computes its own aircraft position and the associated position accuracy using 3 sources: the inertial references, the Global Navigation Satellite System, and radio nav aids including VOR, DME, and localizer. The aircraft position function of each ADIRS provides the aircraft systems with the most accurate position that is available using the following priority: the Consolidated Global Positioning and Inertial Reference System position, the ADIRS' own Global Positioning and Inertial Reference System position, the Inertial Reference Radio position provided by the Flight Management System, and the ADIRS' own Inertial Reference position. When the Global Navigation Satellite System data is available, each ADIRS uses the Global Navigation Satellite System and the inertial reference sources to compute a hybrid position referred to as the Global Positioning and Inertial Reference System position. When the Global Positioning and Inertial Reference System positions for the 3 ADIRS are available, the ADIRS compares the 3 Global Positioning and Inertial Reference System positions and selects the most accurate one to provide a consolidated Global Positioning and Inertial Reference System position. The Flight Management System uses the Global Positioning and Inertial Reference System consolidated position whenever the Global Navigation Satellite System information is available. During normal operations, ADIRS 1 and ADIRS 3 are supplied by Multi-Mode Receiver 1, and ADIRS 2 is supplied by Multi-Mode Receiver 2. If one multi-mode receiver fails, the remaining receiver automatically supplies all ADIRS. The Flight Management System computes a position based on all of the available inertial reference sources and the available radio nav aids. This position, which includes the inertial reference data, is referred to as the inertial reference radio position. Each ADIRS computes a position based only on its inertial reference source, referred to as the inertial reference position. Each ADIRS continuously computes the estimated position uncertainty, EPU, that is related to the computed aircraft position. The estimated position uncertainty is computed by its individual ADIRS. The estimated position uncertainty value corresponds, in nautical miles, to the radius of the circle around the computed aircraft position within which the real aircraft position is located during 95% of the time. The Flight Management System uses the required navigation performance (R&P) value together with the estimated position uncertainty value to define the navigation accuracy. Required navigation performance refers to the level of performance stated in nautical miles required for a specific procedure or a specific block of airspace. The flight management system uses a default required navigation performance value. A terminal area procedure may have an associated specific required navigation performance value defined in the navigation database. The flight crew can manually overwrite the flight management system default or terminal area procedure value. The flight management system continuously compares the current estimated position uncertainty from the ADIRS with the current required navigation performance and defines the navigation accuracy as high if the estimated position uncertainty is less than or equal to the required navigation performance, or low if the estimated position uncertainty is more than the required navigation performance. The aircraft is in navigation primary mode when the two following conditions are satisfied. The navigation mode is Inertial Reference System, Global Navigation Satellite System, and the navigation accuracy is high. Note that when the navigation status is navigation primary, the navigation accuracy does not appear. If at least one of the two above-listed conditions is no longer satisfied, the aircraft is no longer in navigation primary mode, and the navigation primary lost message displays on the MFD and the ND. The MFD position monitor page displays the required navigation performance, the estimated position uncertainty, and the navigation primary status. The PFDs display the backup speed indication or backup altitude indication from the Full Authority Digital Engine Control FADEC computers and angle of attack probes when the automatic monitoring of air data by the PRIMs and ADIRS rejects the 3 air data references and the integrated standby instrument system air data. Or, the flight crew detects an unreliable air data indication and manually selects the display of the backup speed and backup altitude indications.